A radioactive decay causes two events. The nucleus changes, and at exactly the same time a particle is given off. We can describe a decay using a decay equation. For example, this decay equation shows how polonium-210 changes into lead-206 by giving off an alpha particle. The equation says that an atom of polonium changes into an atom of lead. In other words, a completely different element. We know there is a change of element because the number of protons changes from 84 to 82, and it's the number of protons that defines an element. The whole point with Dalton's atomic theory was that atoms couldn't just change from one element to another. But with the discovery of radioactivity, it became clear that they did this all the time. Let's go back to Rutherford's lab in 1902, almost 10 years before he figured out that atoms had a nucleus, and therefore before the discovery of the proton. He was investigating the radioactivity of thorium, and he noticed the radioactivity dropped suddenly when someone came into the room. His conclusion was that thorium was actually turning into a new element, which was a gas. The new element ultimately acquired the name radon. His colleague Frederick Soddy carried on investigating and discovered that the nucleus of a radioactive atom often went through several decays before finally becoming stable. He found that there were 3 natural decay chains, each of which ended up with an isotope of lead. There were elements that were common to all 3 decay chains, for example radium, radon and polonium, and sometimes the same element appeared twice in the same chain. Even though the elements are the same, the isotope is different for each instance. We can now explain what was going on. An alpha particle consists of 2 protons and 2 neutrons, so it has an atomic number of 2 and a mass number of 4. It's identical to a helium nucleus. When an alpha emitter decays, the new element has 2 fewer protons, so it changes to an element with an atomic number that's 2 lower in the periodic table. A beta particle is just an electron. Electrons have a tiny mass. You need roughly 2,000 of them to have the same mass as a proton, so we give them a mass number of 0. Because a beta particle is negatively charged, we give it an atomic number of -1. When a beta emitter decays, the new element has 1 extra proton, so it changes to an element with an atomic number that's 1 higher in the periodic table. Gamma is just light with no mass and no charge, so it has a mass number of 0 and an atomic number of 0. Gamma decay leaves the number of protons and neutrons the same, but they're arranged into a lower energy state. This table shows the journey of a single nucleus for each of the 3 natural decay chains as it decays to stability. As you go from top to bottom, the nucleus gets smaller with alpha decay. As you go from right to left, the nucleus changes elements. Sometimes the chain goes from alpha to alpha, decreasing mass and changing element each time. Sometimes, after an alpha decay has reduced the atomic number by 2, you get 2 beta decays. Each beta decay creates a new proton from a neutron, so the atomic number goes back up by 2, and you end up back at the same element, just with an isotope of a lower atomic mass.